Oh, okay. So I want us to look into the advanced IP address subnetting. So
Mm.
the topics that we're going to cover today is just a basic of classful and classless subnetting recap, the one that we did in the
Mm.
previous class. Then the binary representation of IP addresses, a method of calculating the number of subnets and the host during subnetting, and now these are now the case scenarios. Number 4 and 5 are now case scenarios where we're going to do subnetting based on the number of subnets specified. Number 5 just do subnetting based on the number of hosts specified. So a quick recap for number 1. Just move up just for a recap. Okay. Okay, so we see that both classless and classful subnetting is just a method of dividing a network IP address into into two or more smaller subnets. So we see that just minute. Okay, so we see that subnets should have the same size and determine the maximum number of hosts per subnet. Subnet mask is used to configure subnets. I think the English there is not correctly written, but subnet is used to configure subnets. Okay, we use IP addresses and subnet mask to do subnetting. So we only use IP address and subnet mask to do subnetting, and we see that each subnet has its own block size for subnetting as shown below. So during subnetting, we use the concept that is called block size. So we use subnet block size table. So for example, any subnet mask that is ending with 128, the block size is 128. When it ends with 192, the block size is 64. So what do you mean by block size? Block size is just a step where you can move from one class to another, from one subnet to another. So that
So that means there is like a given number of IP subnets, like 128.
yes.
So,
Yeah. So when the numbers are there, now block size is just a number that helps you move from one subnet to another. All the steps that we're going to pass through to the other number. Yeah. So for example, let's say the first subnet starts from .40 and the second subnet starts from .60. So you take 60 minus 40, you find 20. So 20 is the block size, is the step from 40 to 60, something like that. Yeah. So etc. From, let's say, when the subnet mask ends with 2224, we have block size of that one. Okay. So we are going to understand them, and we are going to understand them better when we start calculating subnets. So example of a classful IP subnetting. So you are given a network of this one and a subnet mask of this one. Now you have been asked to find a network ID, first and last valid host IDs, and broadcast ID. So I'll explain the four terms. Network ID is just the network address per subnet.
And network ID is the network, like is it the difference between network ID and the IP?
No. IP is the general term. It's just the general term. So under IP, so we said that we calculate subnet using IP address and subnet mask. So the main function of the subnet mask is to tell us which part of that IP address is the network ID and which part of the same IP address is the host ID, or the host ID. So IP is just a general term. Now network, we use subnet mask to identify which part of IP is network ID and which part of IP is host ID. For example, when we were looking in the classes just here, so we could see that with the help of subnet mask, we have identified the first part is a network ID and the last three parts are the host ID. Yeah, something like that. Yeah. Okay.
Okay.
So based on this scenario, this is the network and this is the subnet mask, and we've been asked to calculate the number of subnets. So given this scenario, you check the last octet of the subnet mask. Yes, you check the last octet, and you compare it on this table. Where does the 0 fall? 0 fall within 128 range, because it's from 0 to 128, then 128.
Oh, yeah.
Yes.
Yeah.
So 0 falls within 128 range, and when you compare, when you 128 range corresponds to, is directly related to 128 block size. So this is the step that will help us move from one subnet to another. So let's calculate the subnets. Now in the first subnet, we'll have that's the normal network address as given here. The first subnet should always have the first network address given here. Now for the second subnet, we add the block size. We add that 228. Now it becomes this one. Now how do we now
repeat that?
Okay, I will repeat. After we have identified the block size, now we calculate the number of subnets. Yes, remember the range of IP is from 0 to 255. Yeah, so if you multiply this by 2, if you divide 255 by 2, you get something like 127 or 128, something like the 127.5, which is 128. So 128 goes into 255 2 times, meaning now we have 2 subnets. I don't know whether you're understanding. The complete octet value, decimal value, is 255. You know, a complete subnet mask is always 255. 255. A complete subnet mask. Sorry. Is 255. 255.255.25. A complete, which is a broadcast a subnet mask. But now for a class C, it always like this: 255.255.255.0. So the 2555 represents the network portion, while the 0 represents the host portion. So after you have identified the block size, now you divide 255 with the block size to get the number of subnets. For example, our block size is 128, while a complete mask is as a value of 255. So you divide this with this 255 to get the number of subnets. So that's why we have 2 subnets here, which is subnet 1 and subnet 2. Now let's go to this question. The question needed us to identify network ID. Let's go for the first subnet. The network ID of the first subnet should just be the given network with this, which is this one. Then skip it. Don't write this one still. Don't write this one still. Skip it and come to network ID of the second subnet. Skip it by adding 128 so that you finalize on the network address of the second subnet. After writing the network address of the second subnet, now is the time to identify which is broadcast ID, or what is the last valid host ID, and what's the first valid host ID. The broadcast ID is 1 this one 128 minus 1 is the last step in this subnet, because in the second subnet it starts from 128. Now in the first subnet it should end on .127, and now last valid ID should be the one that follows this one, 126, but first valid ID is the one that should follow this one. Subnetting is kind of challenging, but when we handle a lot of problems, we will understand them better. That's why we come up with the first valid ID as this one, because this one was network address .0. It's a network ID. Now first valid host ID should take +1, okay? And broadcast, you take 1 from this one to put here. And now last valid host ID, you take 1 from this one also to come up with 126. So the same thing applies here. The first valid host ID under second subnet is, you had 1, you come up with 129. And this is a broadcast. When the block size was 128, you add another 128 here, you will get 256. But 256 is not applicable. It normally ends at 255. So the 255 is the last one. Now last valid ID, you minus 1, you get 254. Something like that. But we're going to understand them better when we handle a lot of problems. So I move on to the next problem. Let me hide that. Okay, give an example of this one and the subnet mask of this one. So before I move to this one, I want to tell you this was a classful subnetting, because you could see the subnet mask was an actual subnet mask of a class C address, and this was a class C IP address. So in the second case, although this is a class C, IP address, but the subnet mask is not a class C subnet mask. So this is a classless subnetting. Now we need to calculate network ID, first and last valid host ID, and finally broadcast ID. So what do? We use a subnet mask to help us calculate subnets. We check the last value of the subnet mask. This is 192. Then we move to the subnet mask block size table. We check where 192 is. Here is 192. 192 corresponds to 64 as the block size. So that's all. After identifying the block size, that's all. Now we take 64. And we know that a complete bits, 8 bits. We identify that each octet has 8 bits, and the 8 bits, when you turn them into decimal, that's why I have this topic. I wanted to explain a lot about what I'm saying right now. 8 bits, when you turn them into decimal, it becomes 255. So you take 255 over this block size, which is 64, to get the number of subnets. The block size is 64. That's good. Now you take 255, which is the 8-bit turns on, and you divide by the block size. You should get a value that's close to 4. Now we have 4 subnets. Now you write subnet 1, subnet 2, subnet 3, and subnet 4. And what you write first is just network ID. The network ID of the first subnet is always the given value, the first given value, this one. Now don't bother this one first. Move to the second subnet and write the network ID, add 64 to this 0, you will get 64. Don't concern about this one first. Move to the third subnet, add 64 to that one, you get 128. Don't care about this one first. Then move to fourth subnet and add 64 to this one, you will get 192. And now you start calculating this one now. First valid host ID, last valid host ID. How do we calculate first valid host ID? You just add 1 to the network ID and you get. Also here you just add 1 to the network ID and you get. Same applies here. Same applies here. That's how to calculate first valid.
First valid ID. First valid ID is like the next.
Yes.
You add 1.
Yes, from the network
to the
ID.
network.
The first one. Yes. So
you add 1.
Yes.
To the network ID.
Yes, you add 1 to the network ID. So after calculating the first valid host ID, pass this one first. Pass or last valid host ID. Come to broadcast. So broadcast is the last step in that subnet. When you go to the second subnet, you can see the starting IP is .64, meaning the previous IP should be .63. So that .63 is the broadcast ID of the first subnet. Subnetting is a little bit challenging, but when we handle a lot of problems, you will understand them. Yeah. The first thing you do, you understand a network ID, you calculate for all of them. Then you calculate first valid host ID for all of them. Then you pass last valid ID first. You come to broadcast ID. How do you know broadcast ID? You check a network ID of the next subnet. It is starting from .64, meaning the previous one was .63, which is the broadcast ID of the first subnet. So after identifying the broadcast ID of the last subnet, of the first subnet, now you are able to calculate the last valid ID of the first subnet. You just take 1 from this one, because this is the last now, this is the second last, is the second last. Something like that. It's very easy. And also, here we have identified first valid host ID. Now let's pass, we pass this one first, then we come to broadcast. We check a network ID of the third subnet. We find that it's ending with 128, meaning the broadcast ID of the second subnet should be 127. Then when the broadcast ID is 127, the last valid ID should be 126, something like that. And the same case will apply to third subnet and the fourth subnet. So that's how it's done. That's how it's done. But you're going to understand them better when we start analyzing the real case scenario. Okay. Also, there is an alternative method of subnetting that you're going to use to calculate the previous problem. So these are the network and subnet mask. Remember, this is a classless subnetting. And what we do, we change this one into binary representation. Whenever we change this one into binary, 2555 is always 8 bits. All the network bits are on. All the network bits are on. Whenever you see 0, that's a host bit, but all the network bits are on. Sorry, I'll delete this one. Where is our eraser? Okay. So these are the network bits, but these are the host bits. That's why I'm telling you this is a classless IP addressing, because you can see for a class C, all of the third octet, this one, I mean the last octet, the fourth octet should always be 0. But because it's a classless, some of the network bits have been borrowed. So we use a concept of borrowed bits. All right. So our network bits are represented by ones. Host bits are represented by 0. Considering the above, the binary values above, the borrowed network bits are 2. So these are the borrowed network bits. Because you just see that this was a class C IP address, and now it's supposed to have three network portion and one host portion, but some of the network portion are found in the host portion. So those are the borrowed bits. So 2 of them have been borrowed. If you convert 192 to binary, you get this one. If you convert 255 into binary, you get this one, this one, this one. So these are the number of borrowed bits. So when we have identified the number of borrowed bits, now we can calculate the number of subnets. How do we calculate number of subnets? Well, we have a formula that is called 2 raised to n. 2 raised to n is a way of calculating the number of subnets in a network. So n represents the number of borrowed network bits when calculating subnets. But when we're calculating the number of host devices, n represents the number of net host bits. So, for example, in this case, the number of subnets will be 2 raised to n, which is 2 raised to 2, because the number of borrowed bits are 1, 2, so which is 4. And the total number of hosts per subnet, we say 2 raised to n minus 6. And now, when we are configuring, when you are determining the number of hosts, you represent the number of zeros. So in this network, we had how many zeros? 1, 2, 3, 4, 5, 6. So raised to power 6 minus 2. So the number of hosts per subnet is 62. So with 62, when you come back here, with 62, we come back here, we add 62 because, just a minute. With 62, that's the number of host per segment, I mean, subnet, sorry, per subnet. 62 is now host per subnet. So when you come here, we said that the value of the first valid host ID is 1, and the last value is 62. So from 1 to 62, just 62, which is
62.
Yes, which is this value. Yeah, because 0 was a network ID, while 63 was broadcast ID. So after identifying that this one is 62, you can just relate here also. You can see that the first valid host was in each segment there are 62 hosts. For example, from 65 to 126, those are 62. Although if you minus them directly, you'll get 61, but you start counting from 65. If you start counting from 65 to 126, you will get 62. So that applies to all the cases. Okay. All right. So I think we are done with the recap, which was quite much easier. So it's the time that we do what's called a binary representation of IP addresses. So that one I will just open Notepad. I will open Notepad. Binary representation of IP addresses. So for example, let's say you have a subnet mask of some 255.255.255.255. Yeah, so a subnet mask is just for 4 octets. So we want to convert these into binary. Yeah. So whenever you want to convert this into binary, you normally use a scale of 128. This is a scale 128. Half of 128 is 64. That's a scale. Then half of 64 is 32. Half of 32 is 16. Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. And half of 2 is 1. Okay. Alright, so this is the scale that we use to compare these values. So if you add all these values, you will get 255. So this is the scale that we use to convert any IP address to binary. For example, if you take 255, just a minute, 255 goes into 128. I don't know how I can explain this. 25 goes into 128. How can I say this? Just a minute. Goes into 128. Well, we say 128 can go into 2555 once, not twice, because twice is 256. So now we subtract, it remains 127. So 127, 64 can go into 127 also once, remaining around 63. So 32 can go into 63 also once, remaining 31. 16 can go into 31 once, remaining 17. Yes, so 8 can also go, 16 can go into 31 once, remaining 15. So 8 can also go into 15 once, remaining 7. 4 can go into 7 once, remaining 3. 2 can go into 3 once, remaining 1, and 1 can go into 1. So this is the binary representation of 2555. So we just write 1, 2, 3, 4, 5, 6, 7, 8. So 2555 is represented by 8 ones. 1, 2, 3. Yeah, 255 is represented by 8 ones. Yes. Now 0, you take a scale of 0. 128 doesn't go into 0. Now we put there 0, remaining 0. Remaining 0. 64 doesn't go into 0, remaining 0. So it's 0, 0, 0, 0, 0. So here is 8 zeros also. 1, 2, 3, 4, 5, 6, 7, 8. So this is the binary representation of this subnet mask. So for example, we had an IP address. Let's have another case scenario. We have an IP address, for example, 192.168.1.0. So we want to turn this into binary. We just use this scale, a scale of 128, 64, 32, 16, and 8. We put it somewhere here. Now we take 192 and change it into binary first. So we come under this scale of 128, 64, and so on, and check. 128 goes into 192. That's okay. It goes once. How much is remaining? It's remaining 192 minus 128, which is 64. So 64 goes into 64 itself. Okay, but remaining 0. So now we put 0, 0, 0. Sorry. There 0, 0, 0, 0, 0. That is for 192. Then let's convert this one. 168. 128 goes into 168 one time. Just once. remaining around 40. So do 64 goes into 40? No, that is 0. Still remaining 40. So do 32 goes into 40? Yes, it goes once. Remaining 40 minus 32 is around 8. Okay, so we are remaining with 8. Do 16 goes into 8? No. Now there is 0. Now does 8 goes into 8? Yes, yes. Remaining 0. Now if it remains 0, we just put 0, 0, 0. Yes, should be 1. And now this is 164, 168. Now let's change one. Well, let's convert 1 into binary. We just use this scale. Does 128 goes into 1? No. Now does 64 goes into 1? No. Does 32 goes into 1? No. Does 16 goes into 1? No. Does 8 goes into 1? No. Does 4 goes into 1? No. Does 2 goes into 1? No. Does 1 goes into 1? Yes, only once, and we put 1 there. Now let's convert 0. When you see 0, just turn everything to 0, 0, 0, 0, 0. So the 0, 8 zeros. Just have 8 zeros, and that's okay. And you write that way, 0. So this one was 2 ones. So the correct binary form of 192.168.1.0 is equal to 1, 1, 1, 2, 3, 4, 5, 6. Dot 164 was 101, then 01 also, 1, 2, 3. Then 1 was 0, 0, 0, 0, 0, 0, 0, 1, then 0. And the 0 was 8 zeros. Each octet in binary format, each octet should have 8 values. So make sure even if they are all zeros, make them to be 8. If they are all ones, just make them to be a 1. So for example, also I'll delete this one also and write another case scenario. Let's calculate a subnet mask. This subnet mask dot 255 dot even 224. So we just write a scale of we just start 128 64. Just a minute. Then 64. Then 32. Half 32 is 16. Then 8. Then 4. Then 2. Then 1. Okay. Now we compare this subnet mask against this scale. We start with the first value of 255. Does 255 goes does 128 goes into 255? Yes, it goes once. Then you move you subtract. After going into 255 once, what is remaining is 127. It doesn't go into 127 anymore. Now we submit it to the next scale value, which is 64. Does 64 goes into 127? Yes, once. So what's remaining? Around 63. 63. Does 32 goes into 63? Yes, once. What's remaining? 31. Does 16 goes into 31? Yes, once. What's remaining? 15. Does 8 goes into 15? Yes. What's remaining? 7. Then we proceed to 4. Does 4 goes into 7? Yes, once. What's remaining? 3. Does 2 goes into 3? Yes, once. What's remaining? 1. Does 1 goes in 1? Yes. What's remaining? 0. So we write 2555. So that's we've calculated a binary format of 2555. Now let's calculate for 244. I'll do this. Yes. Does 128 goes into 224? 224? Yes. Now what's remaining there? you just subtract. That's around 96 or so. No, not 96, but 224 minus 128 is equivalent to 96. Yes, 96. The 64 goes into 96, yes, once. And now what's remaining is it's 32. Now does 32 goes into 2? Yes, once. What's remaining? 0. Now just write 0, 0, 0, 0, 0. And you write that is 224. And now the binary format of 255.255.255.224 is equivalent to 8 ones of 255 plus this one, 3 ones. So I just do this, copy 1 2 and 1 1 3 1 1 3 4 5. Okay, so this is the best way of calculating IP address into binary. So another way that you can do, you can use Google. You just have to use Google. Just say decimal into binary. Yeah, decimal into binary calculator. Then I just need calculator, convert our calculator, something like that. Yes. We just write the decimal. For example, I just write that decimal and convert. And where's the value? This site is not working. I'll try another site. So we write that and we convert. Did I
scroll down now?
Okay, the best thing to do is just write IP address into binary.
At my end it works.
It works.
Address
into binary. IP address into binary. Yeah, something like this. So you can see it's the same value that we gotten. So it's very easy. It's very easy. Although it's a little bit challenging if it's your first time, but the more you get into it, the more you understand it. So that's the best way to understand how to convert decimal to binary. You can use Google if you're tired, but for your practice purpose, know the both ways, how to calculate it normally, just and how to do it using Google. All right. So the next thing that I wanted us to do is the methods of calculating subnets. The methods of calculating subnets. Basically, there are two methods of calculating subnet. There are two methods of calculating both subnets and hosts. And I'll open this one. I'll say to get subnets for subnets and hosts. So whenever you want to calculate the number of subnets in a network, there is a formula. So the formula is 2 raised to power n. How do we say raised to power n? Raised to power, which symbol can I use there? Actually, there's no symbol on my keyboard. Raised to power n. So let me open Word. Okay, to calculate the number of subnets, we use the formula 2 raised to power, where's the raised? Somewhere here. Raised to power n. This gives us the number of subnets. So what is n? Very important. Let's ask this question: what's n? Because to find the number of subnets, we use 2 raised to power n. So what's n? N is the number of borrowed network bits. So we just say the number of borrowed network bits. And how do we know the number of borrowed network bits? For example, using this subnet mask, which is 255.255.192. How do we know the number of borrowed network bits? We first convert this into binary. And how do we convert this into binary? Use this scale: 128, 64, 32, 16, 8, 4, 2, 1. You start from 128, then you half the way until it is ones. Then let's start from 255. 255 goes in, 128 goes into 255, yes, once. Then it remains 1. It remains 127. 64 goes into 127 once. It remains 63. 32 goes into 63 once. It remains 31. 16 goes into 31 once. It remains 17. 15. And 8 goes into 15 once. It remains 7. 4 goes into 7 once, and it remains 3. 2 goes into 3 once, and it remains 1. 1 goes into 1 once, and it remains 0. So this is what 255. Then for 192, we also calculate here. 128 goes into 192, yes, once. How much is remaining? We take 192 minus 128, we get 64. 64 goes into 64, yes, once. What's remaining? 0. When 0 is remaining, you just write 0, 0, 0, 0, 0, 0 for 192. So, sorry, for 192. So a subnet mask of this one, copy. A classless subnet mask of this one, a subnet mask should end with a 0, but when it's ending with such numbers, meaning it's a classless. So it's having a, this subnet is having a binary representation of 1 1 1 1 2 3 1 2, something like this. Copy. Then the last octet, which is 192, we're having 1 1 6 0 1 2 3 4 5 6. Okay, so we convert first into decimal, then we find the number of n, the value of n. N represent the number of borrowed network bits. For example, in this subnet mask, the number of borrowed network bits is this one. It's only 2. If you compare this network subnet mask, it's supposed to be a class C subnet mask, but because you see some values are here, it makes it a classless. So meaning this is where the values were borrowed from. So we only have 2 borrowed bits. 1, 2. The ones represent the network bits. The zeros represents the host bits. So n in this case is 2. So the number of subnets in this scenario, the number of subnets is equal to 2 raised to 2, and we get 4. The number of subnets are 4 in this scenario here. Okay, just a minute. The number of subnets here are 4 subnets. So that's the way of calculating the number of subnets in a network. You use this formula and you use the subnet mask. What to do? Turn the subnet mask into binary. You can just use Google and check the value that is close to the network bits. You find that they are only 2 bits. Okay, all right. So let's calculate the number of hosts per subnet. How do we calculate the number of hosts? We calculate using this formula: 2 raised to power n minus 2 represents the number of hosts per subnet. So what's n? What's n in this scenario? N represents the number of host bits. That's all. So in this scenario here, the host bits, how many host bits did we have? We only have, the host bits are represented by 0. So there are only 6. 1, 2, 1, 2, 3, 4, 5, 6. There are only 6. So let's calculate the number of hosts in per subnet. So that will become so the number of hosts will become 2 raised to power 6, because the number of n represents 6, minus 2. So that one we get something like 62. So 62 is the number of hosts per segment. Remember, there are 4 subnets, so meaning there will be 62 times 4 hosts in this network. So this is what happened here. When we were doing subnetting, you could see, when we were doing this subnetting, we could see we got how many subnets? 1, 2, 3, 4. And how many hosts per segment? From 1 to 62 is 62. So that's why the formula is very, very important during subnetting. Okay. Yeah. So I believe you're going to understand them better when you start analyzing the case studies. So let's go. Okay, we are done with that one. So let's start analyzing the case studies. So for example, number 4 tells us that subnetting based on the number of subnets specified. I will write this. Okay. Subnetting based on number of of subnets specified. Okay, that's number one. And for this, I will open some simple a simple case study that I have okay, I'll open some simple case study that I have analyzed so far. Okay. Okay, so this is a sample, a case study. This was actually my first enterprise networking project that I did and posted on YouTube. Okay, we are being told that to design a network in Cisco Packet Tracer to connect accounts and delivery department through the following. Each department should contain at least 2 PC. Appropriate number of switches and routers should be used in the network. Use a given network address. That one. All interfaces should be configured with the appropriate IP addresses, separate masks and gateways. All devices in the network should be connected using appropriate cable. So test the communication. That's not our concern right now. Our concern is to do subnetting on this IP address so that to do IP address on this, to do subnetting on this IP address so that the devices in accounts and delivery department can have IP addresses. So I'll just go back here and write the network that is given. Network is 192.168.40.0, and the number of subnets is equal to 2. There are only 2 departments. There are only 2 departments. This is just enough for us now. So the first department, let's say departments, we have accounts and delivery. This information is now just okay for us. I can now go ahead and close this. So we were just given IP address. We were not given subnet mask because we've been given the number of subnets to use in the network during IP address subnetting. So our first the first thing to think is the formula to find the number of subnets, because we want to find the subnet mask. We want to find the subnet mask. So how do we do this? We've been given the number of subnets and the IP address. So how to find the subnet mask? How to find subnet mask? We use these two now. We use these two now. First thing that we do, we see that these are a class C IP address. And for a class C address, we see that the given network is a class C IP address. And for a class C IP address and for a class C IP, they have a standard subnet mask of 255.255.255.0. But we've not said that this is the subnet mask that was used in this case study. This is just a guideline to show us what subnet mask is available for Class C IP address. So, using a formula, using a formula 2 raised to power n should give us the number of should give us the number of subnets. But the number of subnets have been given. The number of subnets have been given. The number of subnets have been given. So we just equate this formula to the number of subnets to find the value of n. The value of n represents the number of borrowed bits in the host portion. So 2n should represent 2, because the number of n represent the number of this value here, 2 raised to n, should give us the number of subnets, but the number of subnets has been given as 2. So let's find the value of n so that you can see how many bits of network portion, how many bits, network bits were borrowed. So we just say 2 raised to n is equal to 2. So what's the value of n? Let's start. 2 raised to 0 is 2 raised to 0. What's the 2 raised to 0? 2 raised to 0, 2 raised to 0 is 1. Yes, I find it now. 2 raised to 0, let me confirm. I believe so. 2 raised to 0, 2 raised to 0. 2 raised to 0 is 1, but now 2 raised to 1 is 2. Good. So n 2 raised to 1 is 2. Now n is equal to 1. So 1 is the only borrowed network bit on the option on the host portion. So the best thing, we convert this into binary. We convert the normal Class C subnet mask into binary. So the normal subnet mask is that one, but when we convert it to binary, we see that it was becoming 1 1 1 1 1 8 ones to yes. We could see that it was becoming that one. Then that was 0 1 2 3 4 5 6 7 8. Good. All right. So this is the normal Class C IPv4 address in terms of decimal and binary, and we see that concerning this case scenario, the number of borrowed bits is 1. This one represents the number of borrowed network bits. Okay. The number of borrowed network bits is 1. So we must design a new subnet mask, because bits have been borrowed. How many? Only one. So a new subnet mask, is, we just write this one, then we borrow here. This is where we borrow it. We just change this into 1. So we just copy, and I paste that on there. And now we change this into 1. We have only borrowed 1. Only 1. And now if you convert this into binary, convert new subnet mask into binary, you get 255.255.255. Now what's this value into decimal? It's 128. Sorry, it's 128. You can just go to Google and you change it, or you change it manually the way I was doing it. So this is the new subnet mask. So for this network, we are having IP address for this network. IP address is 192.168.1.40.0. Then the subnet mask of this one. Okay. So we need to do subnetting, because we found the subnet mask and IP address. IP address was given already. So we found the new subnet mask, which is very important. Now, how do you calculate the number of subnets? We saw that the number of subnets here are 2. Yes. And for the new subnet mask, the binary representation is this one. This one, and the subnet mask ends with 128. Now I want to go back to this table here. When subnet mask ends with 128, the block size is 128. Very important. I'm just done with that table. Subnet mask ends with 128. Now the block size is 128. Now we say first subnet. Because we only have 2 subnets. Now let's start from first subnet. For the first subnet, the network ID, I'll just say net ID, should be just this normal IP address that was given for the first subnet, and jump directly to the second subnet. Don't bother writing other things. Now second subnet, the network ID, copy. The network ID should be this one plus the block size. The block size is 128. I just had 150. I delete this and add 128 there. Okay. Now I go back to the first subnet, and I want first valid host. First valid host should be this one. Just say copy 40.1, the first one. Then also come to last valid host, and I pass that one first, and finally I go to broadcast. Broadcast ID, and we say the broadcast ID is the last IP address in the first subnet, in each subnet, the last IP address in each subnet. The last IP address in each subnet. The last IP address here should be less one less this. I mean this one less one. So that one become 127. Then last valid host ID now should become 126. That's how it's being calculated. Then I come here, come and say first valid host ID, and this second subnet should be 129. We just had one here, okay, and because we had two subnets, and the final value is always been 255. The final value has always been 255. Now, just a minute. Okay, the final value has always been 255. If you have realized that the final value has always been 255, then the last valid host ID under subnet 2 should be 254. So this is what should be used during IP address assignment. We should assign our first subnet these IP addresses, while the second subnet this IP address. So this is very, very important. This is very, very important. Very simple. So I want us to do the second scenario that's similar to this one. I want us to do the second scenario that's similar to that one. This one. Okay. So we have a company that is upcoming, and I don't need to read all those. I just want this IP address and the number of subnets, and the number of departments or subnets. So we see that in this network we've been given a network address and the number of departments. How many departments? 3 of them. So the same thing that we did here. I'm just going to copy some parts. Until somewhere there. I'm just going to copy some parts. Yes. So we've been given a network of 192.168.1.0. So 192.161.0, and how many? The number of subnets is the number of departments is 3. And the departments, we have the departments as IT, HR, CS. So just for abbreviation, IT, HR, and customer service. Okay, now we want to find the subnet mask. We've just been given IP address and the number of subnets, but it's very, very important to find the number of subnet. To find the subnet mask, because you cannot assign IP address without subnet mask. So we must do that before we can do anything. That's why we do subnetting. Okay, how to find subnet mask? We see that a given network is a class C and IP address And for class C IP address, they have a standard subnet mask of this one. This is a class C IP address, and we see that a class C IP address has a standard subnet mask of that one. Okay, using the formula of this one should give us the number of subnets. So 2 raised to n should give us 3. I put here 3. Now what's the value of n? 2, when we make n 0, then this one should be 1. When we make n 1, then this one should be 2. When we make n 2, this one should be 4. So which one should we take? We should not take a value that gives us less IP addresses or less subnet. We should take a value that gives us an exact subnets or slightly above that subnet. So let's assume that the number of the value of n is 2. It will give us 4. 4 subnets can accommodate 3 subnets, but when we make n to be 1, it will only give us 2 on this side. 2 subnets cannot accommodate 3 subnets, so n should represent 2, and 2 represents the number of borrowed network bits. So when you convert the normal class C subnet mask into binary, we get this one. But now we want to borrow how many? 2 network bits. Now we come back to the last octet and borrow 2. This one, we borrow them. This is where we borrow, that's where we borrow. Yeah. So we borrow 2 and we change them to 1. Because network bits, we borrow 2 network bits. Network bits are represented by 1. Host bits are represented by 0 on subnet mask, not IP addresses. Okay. And now when we convert this into binary, when we convert into decimal. When we convert this into decimal, we get that one plus this one, we got around 192. 192. Good. We get 192.
How?
Sorry?
How do you get 192?
When you convert this into binary, I can
yeah.
I can just take this. I copy and go back to internet, and I say I'll say IP address into binary. No, I need binary into IP address, but no problem. Binary into IP address. Binary into IP address. And I convert to IP. Where is the answer?
I think what you're doing is convert.
Sorry? I made some.
Can you check the tab?
Yes. Okay, you can see it there. I made a mistake. There was some spaces here. Then we see convert to IP. You can see this is the new subnet mask. That's the new subnet mask. And now the IP address will be 1.0, and the new subnet mask should be 192. Okay. So we've been told that there are 3. We need 3 subnets. So we just have to move to the first subnet. I'll go ahead and copy what I did above, this one. I'll go ahead and copy and come paste here. So the first subnet, we said it's just a normal IP address that was given. Then you run to the second subnet and you use what's called block size. How do you identify a block size? See the last value of the subnet mask, and you come here and you see that 192, the block size is 64. Very simple. Now you put 64 here, 1.64. Because there are 3 subnets, I'll move to the third subnet. How can I copy them? Just a minute. No. So this is the third subnet, third subnet. Okay, the third subnet. We add 64, which was the block size, to 64, then we get 128 here. Then first valid OSA D here will become 1.1, 1.1. We had 1 here, then become 1.1. We had 1 here, we become 1.64, 65, I mean 1.65. And here we had 1, and here become 1.129, 1.129. Then we come to the broadcast ID of the first subnet. We see the network ID of the second subnet as 64, meaning the broadcast here should be .63, 1.63. And when the broadcast here is 1.63, the last valid OS should be 1.62. 62. Now let's solve for second subnet. The first thing we do, we calculate the broadcast of second subnet. We see first the network ID of third subnet is 128, meaning for a second subnet, the broadcast ID should be 1.127. 1 less this one, 128 less than 1. Okay, then when that one is when the broadcast ID is 127, then this one should become 126, 1.126. Okay, and because we don't have a fourth subnet, we just had 64 here. We just had 64 here to get 192. We will delete this 192 later, but I just want to calculate broadcast ID. We just had 64 because 64 was the block size. To get 192 of the fourth, let's assume this was the, let's assume fourth subnet should end with dot 192 here. Now because the fourth octet starts from 192, now the third octet should have ended at 1.191. When it's 1.191, then the last valid OS should be 1.190. So I'm free to delete this one because I've found what I wanted. Sometimes it's a little bit challenging, but when you handle a lot of these problems, okay, so that's all about subnetting based on the number of subnets specified. So it's also a very tedious task, or some kind of a very hard task to redo them based on the number of So based on the number of hosts specified. Are you still okay? We can proceed.
Yeah, for like a couple minutes. Yeah.
Okay, no problem. So now we want to do subnetting based on the number of hosts specified. I will open sample case studies. Okay. But this was just a class full. We don't need to do subnetting. This is just a class full. Know much about subnetting. Close that one. Project 4. Project 4. Let me see if there's a let's project 5. Okay, I think now project 5 is okay. We can do project 5. We can do project 5. We can only do project 5. Let me check another project that has not too much of those that are confusing. Okay, I think project 6 is the best to demonstrate this one, because we are being told first floor as sales and marketing department, 120 users are expected, and also HR and logistic, 120 users expected, and so on and so forth. So subnetting based on the number of hosts. So first thing that we do see, the network. The network given here was this one. This was the base network, which is 172.16.1.0, and it was there. It was
That is not class C, right?
yeah. This is a class. This is a class
D.
B.
B.
B. No. We don't use class D and E.
Yeah, I mean that's class B.
Yeah, B.
B as
Boy.
yeah.
This is a class B IP address. So this is the network that has been given. So I'll copy this. I'll copy until somewhere here. Copy until somewhere there. And paste that and change this to 16, 17. Now the number of hosts. The number of hosts. Per subnet. We've been told each department to have at least 120 users. You can see 120 users, 120 users, 120 users. So each department to have at least 120 users. Okay, we still don't have any subnet mask. So with these values, with these two things, we need to find the subnet mask. And if we just derive the concept here, I'll just copy. I'll just copy that. Okay, we want to find the subnet mask. How to find subnet mask? We see that this is a class B. This is a class B IP address, and its address, and for class B IP address, they have a standard subnet mask of 255.255.0.0, and using the formula. Now the formula of finding the number of hosts, because we don't have subnet, we just given hosts. So we prioritize on the number of hosts. How do we find the number of hosts? We use 2 raised to power n minus 2 as the formula of finding the number of hosts to give us the number of hosts per subnet. Okay, then 2 raised to power n minus 2 should give us the number of hosts per segment, which is 120. So what's the value of n? And n should represent the number of net host bits in this scenario, because we are calculating based on the number of hosts per segment. Now n in this scenario should give us the number of host bits. So 2 raised to n minus 2 should give us 120. What's the value of n? Let's start calculating. 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, 2 raised to 5 is 32, 2 raised to 6 is 64, 2 raised to 7 is 128. Good. So 2 raised to 6 is 64, but 2 raised to 7 is 128. Minus 2 gives us 126. Even if you have 6 more, no problem. But you should not afford to have less than this value. For example, if we make this one to be 6, it will give us 62, but 62 is less than this one. We better make this one to be a value that will give equivalent result, or slightly more than what is expected. So n
slightly more. It can't be less.
Yes. So n should be 7. That represents the number of host bits in the subnet mask. So we need to convert the number of host bits. So convert the normal class B subnet mask into binary. We find here should be 0. Here should be 0 for class B. Then copy that, we substitute with it, we replace with that one. So this is the normal class B subnet mask, all of this. But we've been told in that subnet mask there are only 7 host bits. There are only 7 host bits. Just a minute, I'll just paste this one here. There are only 7 host bits, meaning all the other bits should be network bits. So let's count. We only need 7 host bits. 1, 2, 3, 4, 5, 6, 7. So let's turn all of this to host bits. Host bits should be represented with by 0. Now if you have found that all the host bits are 7, now what's remaining, we just substitute with 1. We just replace with 1.
I can't hear you.
Yeah,
I just lost.
Yeah. Okay, I'm saying this.
Are you talking?
Can you hear me?
I can't hear you.
Can you hear me now?
Mm-hmm.
I'm sorry, it was my network issue. It was my network issue. Where did you get me last? Hello?
Yeah.
Where did you get me last?
Okay.
Was I here?
Yeah.
So I was saying that a normal class B subnet mask, when you turn it to binary, it should give this value. But now we are being directed that in this network that we are going to design, the number of host bits should only be 7. But you've been given that this is the normal class B subnet mask. And you're being told that the number of host bits in that network, in that subnet mask, should only be 7. And if you check this normal subnet mask, the number of host bits are 16 because 8 plus 8, those are 16. But depending on the question, the number of host bits should only be 7. So we just count 1, 2, 3, 4, 5, 6, 7. So this one should be host bits, the 7 of these. Host bits are represented by 0. So any other remaining thing should be network bit. Yes, network bits. Because we've been told host bits to be only 7 bits. And everything that's now remaining is network bits. Just convert them that way. Now, when you convert these into decimal, we get around 255.128. So let's check this one. Now that one will be 172.16 1.0 with a subnet mask of 128. The subnet mask ends with 128. And when you come here and check the block size, 128 represents a block size of 128. So you just move directly to calculating subnets, which is very easy, very easy. I'll just copy this one. I copy and I come here and I paste. So the first subnet is just 172.16.0. Then the second subnet, you add the block size, which is you add the block size, which is just a minute, which is 128. So there will become 128. And how many departments did we have? We had a lot of departments.
120.
No, those were the number of hosts, the number of devices. Yeah, per subnet. So we had how many departments? This one is one department combined, another department combined. 1, 2, 3, 4, 5.
2.
We have
3, 4.
Yes.
5.
1, 2, 3, 4, 5 still. I will exclude this for server room because server room we know how to do it. So currently we have 5 subnets. We have 5 subnets. Now I just copy again. Copy. And something like that. So this is the third. And this is the fourth. And finally this is the fifth subnet. Okay. So when we find that
And the lastly, you said the second subnet again down there at the end.
Oh, this one should not be here.
You have to delete those. Yeah.
Should not be here.
So for the first subnet, we take the given network. The first host is
yes. Then when we come to second subnet, we had the block size. And when we come to the third octet, we still add the the block size, and it will give us 256. 256 basically, you know, I will tell you that the end of the full binary number is 255, not 256. Now when it comes to 256, now this second value changes. Now here changes to 2 because the first octet is full. Now it overflows to this one. When we add 128 to 128, it gives us 256. Now meaning 1 is missing, so 1 comes here and changes this to 2. Even this one, when we add 128 here, it will overflow. 1 will flow here and come 3 and change that one there. So let's calculate these values. Let's calculate these values. For example, the first valid host ID for a first subnet should be, it will be 172.16.1.1. Here it will be 172.16.1.129. Here it will be 172.16.2.1. Then here it will be 172.16.2.129. And finally here it will be 172.16.3.1. Okay, so let's finalize on the first subnet. This is the network ID of the second subnet. Now the broadcast ID of the first subnet should be 127. 127. Now if this is 127, then this automatically should become 126. 126. Hello.
yeah.
Sorry, man. I lost my Wi-Fi network went down, so I couldn't access internet.
Oh.
Yeah. All right. So I was talking about the broadcast ID and the last valid host ID. So when we move to the second subnet, we see that the network ID is that one.
Oh, can you share? Can you share the screen?
Oops.
And I think for the recording, it didn't get lost.
Yeah, the recording are still here.
Yeah.
Yeah. You can see it's still on. Can you see now?
Mm-hmm.
Yeah. So when you move to the second subnet, I mean, you check on the third subnet. This is the network ID of the third subnet, 2.0. Okay, so 2.0 is this network ID of the third subnet. Now, the broadcast ID of the second subnet should be the last IP address to move to 2.0, meaning it was 1.255. Then here become 1. So it should be this one 7. This one should become 254. Okay. Now let's check on the third subnet. First valid host ID, that's okay. Now broadcast ID. Broadcast ID you check with the fourth subnet. The network ID of fourth subnet is this one, 2.127.128, meaning the broadcast ID of third subnet was the last IP address to move to the fourth subnet, which could be 2.127. Then if this one 2.27, we just change this to 2.126. Okay. Then finally you check on the fourth subnet. The valid host is okay. Now you check on the broadcast ID. The broadcast ID you check with the network ID of the fifth subnet. If the network ID of the fifth subnet is 3.0, then the broadcast ID of the fourth subnet was the last IP address to go to 3.0, which was 2.255. 255 is the last one. So if you move from 255, you jump to another IP address. Okay. Now this one should be 16 and 7. Then this one should be just a minute. This one is 254. Okay. Then we go to the fifth subnet. That's the correct network ID, correct valid host ID, first valid host ID. Then now the broadcast ID. Well, the broadcast ID we don't know how to calculate it without checking the sixth subnet. So let's assume sixth subnet was here. So sixth subnet could be, the block size was 128. Now sixth subnet could be something dot 128 now, because here was 0. So let's assume it was 172.16.3.0. Okay, so this is the network ID of the sixth subnet. So if this is the network of ID of the sixth subnet, then the broadcast ID of the fifth subnet should be 16.3.127. Then if this is this one, then copy and you paste here and change this to 126. Now we've done what we wanted. We delete the sixth subnet because it's not there. So that's how to calculate subnets. How to do subnetting based on the number of subnets given and the number of hosts given. So it's quite much easier, although a little bit challenging. And if you do a lot of practices, you can be able to understand it better. And I always don't like to say this, but there are other softwares that can calculate these subnets. So there's one software that I normally use, is called Advanced Subnet Calculator. Subnet Calculator. I don't have it. So you can just use Google Subnet Calculator. Subnet Calculator. IP subnet calculator. So here what you just do, we just, for example, this was our network. Let's move down here. This was our network. I copy it, I paste it to subnet calculator here. I copy this, and the subnet mask, as you can see, it was 128, 255.255.255.128. So if I come here, I choose one, which one? So 255.255.128, that one. Then I calculate. So you see what we are doing here, just okay. Where are they? I want all of the subnets. I want all of the subnets. I like subnet calculator, IP subnet calculator. That's why I like subnet calculator, because it's subnet. I don't know, subnet calculator. No. So there's software that is called subnet calculators. It helps us to calculate all the subnets as required, and through that software you are able to know which subnets to use in the network. So basically, I think that marks the end of this long class. It was very necessary to do this class because I didn't want to start actual routing before we can learn how to do subnetting. So it was very necessary to do this class. Although it might be very hard to understand, but if you do much practice, you grasp few.
So I'll go first to go through the video, watch the video, and from there I can be able to understand more.
Yeah.
Because there was some point I couldn't understand, and I didn't want to stop you, but I will think with the video.
Okay.
And with the explanation, I will be able to understand more. But so far, I have the image and I know how you can do it, but I will